we started looking at function operations. We looked at addition, subtraction, multiplication, and sum division. And we did not quite finish up this last one. So remember, we were looking at the division was actually pretty easy. The hard part was trying to pick our domain for the function. So remember, we looked at restrictions. First off, when I have a square root in my denominator, we needed to figure out where does that equal 0. The first one was that plus or minus 2. The second one, we just had a square root of x in the denominator. So that gave us x cannot equal 0. On our square root of x, remember we said that x has to be greater than or equal to 0. And on our square root of 4 minus x squared, we said that 4 minus x squared has to be greater than or equal to 0. The only problem was, remember, that we said that this is a non-linear inequality. So we can't just do our normal steps by like adding and taking the square root. So we said first, we find where does this equal 0? Well, it's going to be negative and positive 2. So we set up our number line with those two numbers, and then we tested values. So we plugged in something to the left of negative 2, like negative 3. That did not work. We plugged in something in the middle, like 0. That did make my inequality work. And we plugged something into the right, like 3. And that also did not make it work. So our domain for our g of x was negative 2 to 2. Yes? We all recall doing this yesterday. Now, what we have to do from here is we have two different functions. We have f divided by g and g divided by f. So we have to figure out what is the domain for each of those. And to me, the easiest way to do that is by looking at a number line. Okay? So notice that the three numbers that we have that are going to like kind of come into play are negative 2, 0, and 2. So those are the three numbers we're going to put on our number line. Are we all okay with that? Yes? So looking at A, if my square root of 4 minus x squared is on bottom, what are the two numbers that we said are going to make the bottom 0? No, not make it 0. What makes it 0? That was our first thing that we did. Plus or minus 2. So we know that it can't be 2 or negative 2. Yes? Then the next thing that we found was, so our f of x has to have an x that is greater than or equal to 0. So remember that that gets a filled in circle, because it can equal it, and we would shade to the right. Yes? Do we all remember number line inequalities? Hopefully so. Alright, and then our last one, okay, was our square root of 4 minus x squared. And that was in between negative 2 to 2. So now we have to decide what interval, okay, meets all of these requirements. Are we with me? Because it has to satisfy each of our pieces. Okay. So notice that for my orange graph, we've cut off everything that's before 0. For our blue graph, we've cut off everything that's after 2. And so we have to be between 0 and 2. Can we equal 0? Yes. Can we equal 2? No. So we would have a hard bracket on 0 and a parentheses on 2. And that would be your domain for that first one. Now, would I give you one like this on the test? No. I'm not going to give you one that has all of these things. Now, could I give you one that has just a square root? Yes. Could I give you one that just has a fraction? Yes. Does that make sense? But I want to give you one that combines all of these. That's why we're doing this type of one together. So, on our second one, again, gonna make my number line. This time, since I have a square root of x in my denominator, what can it not be? 0. So it can't be 0. My orange graph is still the same. And the blue graph is still the same. So what's the only difference going to be in my domain this time? It's going to have a parentheses around 0. And can we equal 2 this time? Yes, so it's going to have a bracket around 2. Yes? No? Maybe? So remember, like I said, the two things that we're looking for when we're talking about domain restrictions are, remember when we have a fraction, our denominator cannot equal 0. When we have a radical, the inside stuff has to be greater than or equal to 0. So let's look at one that would probably be more similar to something that I would give you on a quiz or test. Okay? So this says, given f of x equals x squared plus 7x plus 12, and g of x equals 3x minus 4. Find each function. And then indicate any restrictions in the domain. So remember that when we have f times g, that's the same thing as having f of x times g of x. And we can look at it by just plugging in the f and the g that they give us. Now remember with the multiplication that we looked at yesterday, our f was just a monomial, meaning 1, so we just have to distribute. Can I do that this time? Do I just have 1? No. What do we have to do instead? We can't distribute. Distributing is when I only have one thing in front. 5? Yeah, so I'm going to start with x squared. So I would do x squared times a 3x, and then an x squared times a negative 4. And then I would do a 7x times a 3x, and 7x times a negative 4, and so forth until you get through all of your terms. So x squared times 3x gives us 3x to the third, okay? X squared times negative 4 is negative 4x squared. 7x times 3x is 21x squared. And 7x times negative 4 is negative 28x. Lastly, 12 times 3x gives us a positive 36x. And then 12 times a negative 4 is a negative 48. Now, the way that I generally do it is I take my x squared and multiply it by each of the terms in the second. However, some people would rather do x squared times 3x, then 7x times 3x, then 12 times 3x, and then start over and go to your negative 4. That's fine as well. As long as you multiply each of the terms in your first by each of the terms in your second, and then when you reduce, you would end up with the same thing that I get. So remember, now we want to combine like terms. So what are we going to end up with for our x squareds? Positive? Yeah. So I get 17x squared. What are we going to end up for our x's? 8x. And then the negative 48 is just by itself. That would be our final answer. Questions on that? Yes? Okay? So on this next one, again, remember that we're just going to write it as a division. Luckily this time, we're just going to end up with a fraction. We do not have a radical as well. So that's why I said this is closer to something that I would ask you on test. Okay? So this is my division. I'm done with that. I don't have to do anything more. But we do have to think, okay, it's set to write down any restrictions. If I have a fraction, where are we going to have restrictions? When the denominator is 0. So we're not allowed to have a denominator equal 0. So we're going to have 3x minus 4 cannot equal 0. So how would I solve that? So I would add 4, divide by 3, so we get that x cannot equal 4/3. Yes? Questions on that? So, just as a reminder, if we had something where we ended up, say, with the square root of x plus 2, okay, how would I find my domain of that? What do we say we have to look for with radicals? What did we say we have to look for with radicals? What type of restriction do they have? Or what type of numbers are we not allowed? What can't be negative? The stuff inside. So remember, we would need to set our x plus 2 greater than or equal to 0. Yes? Which means that we would get that x has to be greater than or equal to negative 2. Yes? So that would be the domain for a radical. Y'all okay with that? And again, that would be closer to something that I would ask you on a quiz or a test. Or it's either just a fraction like the last one, or just a radical like this one. Questions, concerns, comments on that?